It's very cool. Thanks for having us on, Simon. Well, today we're talking about the PMC-EIGHT line of equatorial mounts.
Of course. It's a beautiful system.
Yeah, starting from the EXOS 100 to the EXOS 2 PMC-EIGHT. And kind of off camera here, we got a G11. The G11 they've been building up for me for remote access, so it's got a lot of extra stuff on it. But we wanted to show kind of the versatility of these mounts and what they can do and everything. So, Simon, do you, where do you start beginners out with this line of mounts? Do you typically start in the middle, or are you seeing more people going towards an equatorial tracker like the EXOS 100?
Sorry, real quick, Scott. I can't actually see where you are.
Oh, okay. I'm here in the studio standing behind the EXOS 100.
Yeah, so the webcam that you've got set up on the Zoom part, is there any way to turn it so I can see you? So I've got a point of reference of what's going on.
Oh, yeah.
We'll get there. There we go.
Can you see us now?
Now he sees us.
Yay!
Yay!
So I'm just going to interrupt into our stream and then pull you guys across.
Okay.
Unmute. All right, guys. Real quick for you guys watching on our stream.
Yes.
We have literally just gotten started. So we've got Scott Roberts over there in his little side there, and we are doing our usual simultaneous broadcast on your stream and our stream. We're more like a BTS, but it's okay for you guys to just, be a part of all of this.
That's
all
right.
So, sorry, what was that question again, Scott?
Okay, so the question was, okay, we've got our two kind of opening price point mounts here from the PMC-EIGHT line. We have the EXOS 100, which is an equatorial tracker, something for small, lightweight telescopes, okay? And then we've got the EXOS 2 with PMC-EIGHT, okay? That's a heavier, medium-duty type of mount. And so my question is how, with the clientele that's buying these kinds of mounts at Woodland Hills, where do you see people mostly going towards? Is it, do they already have a mount or a telescope that they want to start using as a go-to system? Are they starting out with like nightscape photography? What's the trend right now?
I think what a lot of the trend has gone into is a lot of people want to be able to do tracking of some description, regardless of which mount that they're looking at. And in fact, most of them don't know about tracking mounts. They know that the stars obviously move, and general consensus is that I want something that can follow the general movement. Some people will actually come in and say, no, I want one of these or one of these or one of these. So I think people don't necessarily think telescopes right off the bat, unless they're getting something really big. But for most of the people that want to get into it, they're thinking tracking, Milky Way shots, maybe longer focal lengths with, just their cameras.
With their cameras, so nightscape kind of stuff. So it would be, obviously both mounts can do this, but the EXOS 100 was really kind of geared towards that, because it's lightweight. It is, we already have the accessories built on to accept a camera when you add on the dovetail assembly. If you want some more refined adjustment, we have an azimuth adjuster. We have a heavier duty mount in case you want that. When I say mount, I mean a tripod assembly. But as it stands right there at, what is it, like 15 pounds?
It's 15 pounds. For astrophotography, it's 9.
Yeah, that's payload capacity.
Yeah, that's payload capacity.
Yeah, I was thinking of the weight.
Oh, weight's 15.
15.
Weight is 15.
Yeah. So you got something that's pretty small. You can travel with it. You can go chase an eclipse with it. This not only has go-to and all the power of the PMC-EIGHT go-to system, but it also has an auto guider port on it, so you can auto guide with it. And I think that's kind of where we start to separate away from other equatorial tracking type of mounts. Also, there's really nothing else to buy, okay? Although you could buy other accessories, you could pull it right out of the box. get some way to attach your camera onto the mount itself, whether you're buying our dovetail or some aftermarket dovetail, and start shooting.
So here's an interesting thing that I noticed about the EXOS 100. When I first saw that mount, I didn't realize how small it actually was, because I was thinking in my head the GT version was the first one that I kind of experienced, and then when the 100 showed up, I was like, damn, this thing is a lot smaller than I thought.
Right.
I had this, this impulse to go up to it and pick it up, and I was like, is this all this thing weighs? I didn't realize I'd ruined the guy's polar alignment, so apologize for that guy. I was like, this is ridiculous how small it was.
Right.
And can you show somebody, just because you're standing right in front of it, you could pick it up almost with one hand, from what I can tell.
Oh.
Yeah, and it just, the counterweight obviously is what weighs something, but you can see it doesn't. It's just so simple. You can just pick it up and just run off with it. Well,
yeah, and we've got, Tyler's also picking up this lithium-ion battery. So when you get the EXOS 100 mount, you're going to, of course, it's complete. You got a tripod, you got counterweights, you've got a battery pack that takes normal batteries, okay, but the holder, which you can't see very easily, but there's the holder, okay. Also holds Explore Scientific's lithium-ion battery. You have all the cables and everything else that you need. Adjustments to the mount. It has a kind of a twist lock.
It's kind of like the Losmandy one.
Right. It's very similar to the Losmandy type of system, where you can clutch it so that you can get some tightness to it, but you can still move it by hand if you like, okay? Or you can get it, you can just nail it down. And so those adjustments are on both sides. A lot of small equatorial mounts have like little levers that you got to go find in the dark or whatever, and that makes it a little bit tough. These quick twist knobs are easy to find and easy to make tight if you'd like.
Cool. I'm just going to show people on the live stream a picture of what this thing looks like. So there she is. So you can guys get an idea of what the actual mount looks like. It's pretty straightforward. And you know what the funniest thing is I was in the store yesterday and we were all messing around with one of the mounts, and it just happened to be this actual mount. In the corner, I had picked up a battery pack made out of AA batteries. So you got those weird things with the bunches of AA batteries, and I said, "Do you guys want to see something really funny?"
Sure.
So we go up to the mount, plug it in with the PMC-EIGHT, everything, turn everything on, and we put something on there and started moving it. And I said, like, all this is powered with AA batteries, and the guy was like, going, well, "That's actually pretty damn good." So tell me a little bit about the powering of this mount. It's like the guy was flabbergasted to see.
Yeah. So Jerry, we'll get Jerry Hubble to come on this program in a couple of minutes. But Jerry worked really hard.
Good timing. There he comes.
Okay. He worked really hard on the power management of it. And when we were testing it, Jerry was showing me running the PMC-EIGHT with a 9-volt transistor battery, okay? And so he was trying to make it run with a 9-volt, okay? And it did in fact work, but not for a very long time. I don't know. Jerry, we were talking about the power management. By the way, this is Jerry Hubble, who is the developer of the PMC-EIGHT system. And but early on, Jerry was we were just trying to make this thing run off the least amount of battery power as possible. And how long were you able to make it run with a 9-volt battery, Jerry?
Well, trying to recall, the problem was getting the voltage high enough. Now we could actually put 2 9-volt batteries in to boost the voltage up.
Yeah. I remember you made it run for like, I don't know, 20 minutes or something.
Well, it would run for a while. I mean, I've got to look and see what the capacity of the battery is, but it would probably run for a couple hours at least, I would imagine. Probably more than that even. The problem was getting the voltage up. Right now we require 12 volts because of the way I run the motors and the driver voltage, but it could run at reduced capacity. I'd have to change the regulators out, because they're 10-volt regulators to run the motor. So that's to get a little
But that gives us
probably too much
more,
detail, but that's the way they work.
yeah, more thrust, as I like to call it. So as it stands right now with one of our lithium-ion batteries and stuff, I've run these mounts, all three of the mounts that we're going to show you. I've run them all for a weekend, okay, stargazing weekends without having to change batteries, which is nice. So
I can tell you how much power they actually use. So on my bench, when it's running and slewing, uses about 6 to 8 watts of power.
How much is that in amperage?
So it's equal to about 600 milliamp.
That's slewing or just running?
Yeah, slewing 600
wow.
to 700 milliamps probably at the most.
Like nothing basically.
Yeah, so I don't know what the capacity of our lithium battery is, but I would say 8 watts for 8. So an hour would be 8 watt hours basically. I don't know what some batteries give you, 50 watt hours maybe, or 30 watt hours. So
Jerry, the nominal capacity for the battery pack is
30 divided by 8. That's about 4 hours. No, that's 4 hours.
Yeah.
For that, for 30
right.
watt hours, 4 hours of driving maybe. But 30 watt hours is nothing.
No, literally nothing.
Right. Yeah. So you're sipping on the battery, and that's nice. You are, I remember the days where I would take a deep cycle marine battery out, with my, my other, another brand when I worked for another company, their go-to telescope, and it actually would use quite a bit of power, So I was carrying these super heavy 12-volt batteries and the alligator clips and all the rest of it to be out in the desert to make sure I had enough power to run.
Yeah, there's several hundred watt hours.
Mm-hmm.
Right. Exactly. Exactly. And what else can I say about it? The other thing I'll talk about is that the telescope, or the mount, is driven with stepper motors. This is true on all the PMC-EIGHT systems that we have. So we're using a stepper drive system. And one of the dangers that can happen with any kind of go-to mount is that you can get something called cord wrap, where you're slewing here, you're slewing there, and a cable gets caught up, and now it starts to bind up the mount. And if you're not at the telescope to watch this and unwrap it, okay, if it was a system running on DC servo motors, those DC servos can burn up driver chips, they can burn up electronics, it can harm the gear, not the gearing, but the motor itself. And so a lot of go-to systems that are out there, once you do that, you're replacing motors, you're probably replacing motherboards and all the rest of it. If this thing gets cord wrapped, what will happen is you'll hear this really strange kind of resistance sound coming from the stepper motor itself. But nothing's heating up, no driver trips are going to blow, okay? No motors are going to fail, okay? And this could happen all night long. And, so you got some reliability knowing that even if you had an emergency situation like a cord wrap or the telescope tube hit the side of your observatory wall or something, that you're not going to damage things, okay? And that's nice. Plus, the stepper motors are really, really quiet. I mean, this thing sounds like a fine sewing machine when it's running, so I really love that sound. And as opposed to maybe like kind of a more coffee grinder kind of sound that a lot of go-to mounts have. And what else can I say? The drives are belt driven, so you've got very nice precision drives. We have customers that report back to us that they can take anywhere from 30-second to even some guys making 3 and 4 minute unguided shots, okay? With the drives as they are. With an auto guider, we have guys driving the system down to about, sub-arc second. We have one guy reported back 0.3 arc second tracking. So
Yeah.
0.3, okay, on this little guy right here. So that, you know, that sells at the price it does. So it's a high performance mount. We also have a load capacity that we recommend for astrophotographers at 9 pounds, but we have people that put
They push it.
4-inch appos on it with guide scopes, with all kinds of stuff, and they go way past this 9 pounds. So again, if you were to push it and use too much weight on it, where it couldn't drive it anymore, it's not going to burn up the motors, it's not going to burn up the electronics, okay? You just need to back off on your weight. So we wouldn't recommend like putting an 8-inch Newtonian on it or a 6-inch Apo on it or anything like that.
Although I would say there's one thing.
But you're known for pushing the limits there, Simon, so.
The system, to tell you how we designed this system uses the same motors as in the larger EXOS 2 mount PMC-EIGHT.
Yes. So it's got lots of
Yeah.
lots of torque capacity on it. So and okay, I'm glad you asked that because a lot of people are using like the ASI Air. They're using other systems where, you know, onboard computers, that kind of thing. So I'm going to let Jerry answer this question.
We do have a standard ASCOM driver for our mount for the PMC-EIGHT. That's always been included with it. We've also have a community of developers called the Open Go-To community that's really stepped up and developed quite a few tools over the last 3-4 years. One of the early ones was Michael Fulbright, one of our customers and a good friend, developed the Indy driver for the PMC-EIGHT early on, and that's what's included in the ASI Air as part of the Indy platform. So it's been incorporated into the Indy platform for several years now, so that's available. And of course, Indy runs on Linux and on the Mac OS. If you use Mac OS for your system, then the Indy driver is available for that. But so we use industry standard interfaces to talk to the PMC-EIGHT. We also have our open source command language that's available with the when you download the driver, you get the reference manual that includes all the details. And what else do you want to say about that, Scott?
Well, I mean, it is really one of the most versatile go-to platforms out there. I mean, no matter if you want to run off of a Windows operating system, a Mac operating system, a Linux operating system, you've got all that. Plus, I mean, for beginners, we typically recommend that they just go ahead and download the application called Explore Stars and run off of either an Android tablet or a iPad. Okay. And you want to demonstrate that?
Sure, I can do that.
Let's let Tyler do something.
Scott's taking over the show, so I'm going to do something.
I did.
So it's very simple, Simon. It really is. So I'm going to take my lithium-ion battery. I'm literally just going to turn it on. I don't know if you can see the tablet, but I'm going to just power it up. Once I enter the secret password.
Jerry, you were able to connect to a tablet and show what the display looks like. Can you still do that?
The lamp pole is in the way. I think Simon said something about move forward or back, maybe.
I can move them.
Here, how about if I move off camera here?
How's that, Simon? Is that better?
Yep. Okay, that's good.
Okay. So I'm going to unplug this. So we got the mount turned on now. When I'm in my Wi-Fi settings, so I'm going to sit here and I'm going to connect to the PMC-EIGHT, which I've already entered the password, which it's literally capital PMC dash capital E for 8. And once it hooks up and you've downloaded Explore Stars, I'm going to open up Explore Stars here, which this is the whole main menu that you will see. Is we got a compass rose over here on the left. We have our coordinates that we have here. We know that we're parked because my deck's at 90, but right now we're just going to hit menu. We're going to go to catalog, and we got an enormous catalog database here. Jerry will have to go over the specifics on how much is in here, but it is quite a bit. But I'm going to hit solar for planetary. We're going to go to the sun, and
objects in it.
and that's it,
And
Simon.
by the way, we've got counterweights on there, and you can see that it's driving unbalanced.
It's unbalanced, and it's just moving like butter. And can you hear the noise, Simon, at all?
What noise?
Exactly. That is it. I mean, this thing will run a DSLR. I've pushed it to a 102. That's how much I've pushed this mount to. Now, like Scott said, there are customers, and I believe it's had an SCT 6-inch on there. And they've gotten some great planetary with this. Granted, you're going to have skying conditions and all that stuff that take effect in it.
Right.
But that shows you what the capability of this mount can do.
So, and guys have done a ton of deep sky work. Now, it's a great equatorial tracker for night sky, Milky Way stuff.
Oh, it's beautiful.
But how about deep sky stuff? Who is it? Wade Prunty.
Wade Prunty did 100 hours on NGC 7000. 100 hours. Granted, it took him a while, but it was amazing the detail that that gentleman was able to get.
Right.
With just this wonderful little machine. So we've flew to the sun. Now I know it's not correct, of course I'm facing it towards the camera, but say I want to park it now. I'm literally going to go back to menu, going to go into settings, and down here at the bottom left, we're going to hit park, and we're done. It's that simple.
So let's just say you've got some extreme focal length happening, and you're doing whatever it is you're doing, looking at the moon for argument's sake, and you've got, say, like a 3x Barlow, and you've already got like 400, 500, 600 millimeter focal length, so we're effectively 2000-ish. What if I want to like pan around, because that's probably one of the biggest things that people are concerned about.
So depending on if your setup has a right angle finder or a straight through finder or a red dot, you have the ability to select the speeds that you want to manually move them out with the compass rose here. So we'll just say I'm a little off target. I'm going to hit 9, and I'm going to slew
Which
just
is
a little bit.
fastest speed.
Which is the fastest speed, and I'm just using it for argumentative sake so you can see the mount move. And you also have D-pads down here on the lower right. You have up, down, left, and right as well, in case you're not comfortable with the compass rose. Some people like the normal, the old guiding system back in the day. It's the up, down, left, right. That's how versatile this mount is with this app. And same with serial. You can do it. It's the same thing on a computer screen, just bigger. Makes it a lot easier to see, and as Jerry said, it is performed for, or it's standard for all ASCOM drivers, so you can use Nina, SGP, oh lordy, what else, the ASI Air. So I mean, it has virtual amount of capabilities to use whatever you want it to use for.
Right, and think of all the ASCOM compliant planetarium software that's out there.
Sharp Cap, you have Fire Cap, you got all that stuff.
Right.
I'm always going to challenge somebody out there to say, run this thing with the Sky X, just to see what happens. Do a bunch of T-point models.
It can be done.
Oh, someone's done it?
Someone's done it.
Who?
His name is George Lutch.
Of course it's him.
He says what would be the challenge of running with SkyX?
It's just a different planetary software that you can use.
Yeah.
Just ASCOM
I use
compliant.
the Maxim DL in our observatory to run the PMC-EIGHT. It'll work with any ASCOM client as long as it's coded correctly, I would say. There are some programs that have a little quirk to them. I know Carte de Seal had a little quirk a few years ago.
Yep.
Stellarium is a little quirky sometimes. But overall, any ASCOM client that can connect to it and run them out will run the PMC-EIGHT.
Okay.
And Indy too.
Oh yeah.
Okay.
Indy driver.
Now we haven't talked about. Okay, so we've talked about how you can hook it up to your desktop computer or a laptop or whatever, and we've shown how it can run wirelessly. Okay. And by the way, very soon we're about to release a iPhone and Android for phone version with what's called Explore Stars 2. Okay, so you know, and these apps are free for download and all the rest of it. But one of the other things you could potentially do is you can run it. You can be cabled in.
You can do both.
And have Wi-Fi turned on at the same time, so you can have a tablet. You know, while you're working with your scope, maybe at the scope you want to just adjust things or whatever, or find an object, and then you can set down at your mission control and drive it at the same time without really having to switch anything. Okay,
wow.
So that is also unique, I believe.
It is. That's very unique.
With go-to mounts. Usually go-to mount, you have to set up one way or you have to set up another way. Doing both simultaneously is not easy to do. And
No,
that's
it's
something
not.
we could do now with the PMC-EIGHT
Yep, that was
systems.
the additional, when we released an updated universal firmware, which basically we have one firmware to install for any of our mounts. But that was a big part of the work we did last year, was to add that simultaneous communications to where you can have two controllers basically that smartly switch back and forth between the two, and it's pretty much seamless for the user.
Yeah.
And that's to be able to control the mount with the computer, but also use your tablet. If you walk out, if you got your computer in your house running it and you go outside to do something, you've got the Explore Stars connected to it. You can maybe update the target or do whatever you want while you're out there, and it'll reflect it back onto your planetarium program on your ASCOM driver in real time.
Yeah, and that's totally cool. That's totally cool. So, of course, when you have a computer, connected to this with a cable, you also, that same computer, that desktop computer, can be connected to the internet. And so you could use something like TeamViewer or Zoom or Type B and C or any of these kind of computer screen sharing programs. And now you've got the power of the internet to allow your telescope to be operated from anywhere in the world. You can run it, from your house to the backyard, from your house to, Arizona or some distant site, or from Australia to France, for example, if you'd like. Okay, so, heck, if the guys on the International Space Station had internet capability, they could operate it from there. So a very nice system. This is technology. My gosh, when we saw computerized telescopes as amateur astronomers visiting professional observatories and stuff, well, they started to control them robotically, computer control and stuff. We just, it was multi-million-dollar technology, and I remember talking to my friends saying, one day,
it will happen.
amateur astronomers will be using this, and we were all thinking, yeah, if we mortgage our house, or we sell that boat or those motorcycles or whatever that my third car or whatever, I can get something. But now we're just talking literally just a few $100s to get into it.
Just to get into it, you bet.
It's totally cool. So why don't we show? Why don't we move this mount and bring up the?
I'll get the other one because she's a little heavier.
Yep.
It's polar alignment. How's the polar alignment done with the PMC-EIGHT?
Okay, well, you would do a traditional polar alignment. Okay, we have a polar alignment tunnel in the system. If you're using our tablet and you're doing a 2-star polar alignment or a 2-star alignment, let me just say that. If you're not on the pole, okay, the PMC-EIGHT will know that and still find everything up in the sky and track. So let's just say that I'm on my patio, I got a tree blocking the North Star, I can't, I don't want to drift align it, I don't want to do all that other stuff. As long as you can pick out a couple of stars, okay, during the 2-star alignment method, it will track, okay, and find everything in the sky that you can see, okay? But if you're an astrophotographer, you can use, we're releasing a free download for a 3D printable adapter for the QHY Polemaster. So you got a Polemaster, stick it on there, bam, you're done. Okay. You can use, we have a polar alignment viewfinder that will fit onto the EXOS 100, and you can use that in northern or southern hemisphere, no problem. Or you can go old school like me.
Laser.
I don't use a laser.
I use, sometimes I've used a laser.
Do you?
It helps.
Just aiming at
Just lit right up, just it goes straight through.
straight through. Well, there
Straight
you go.
through. Makes it easy.
That's another easy way to do it. Or, you know, I do drift alignments. I just like doing drift alignments. You know, a lot of people think that's a big pain. I think it's fun. Okay, that's how much of a nerd I am, guys. So, all right. So let's go to. Sorry.
Because people don't understand what drift aligning actually is. It's like a lost art, is what it really is.
Yeah, I agree with you, Simon.
I think so.
Yeah.
And so we have on the Explore Scientific website, we actually have a step-by-step method how to do drift alignment. But effectively, what you're doing is you're pointing the telescope at a star roughly overhead, but still at 0 degrees declination. Okay, and you're putting in a crosshair eyepiece. And you're watching to see if the star will stay in the center of the field, not drifting north or drifting south, okay? If it drifts north or south, you make an azimuth adjustment. If you go the wrong way, you'll see the star drifting faster. If you go the right way, okay, it's slowing down or stopped, okay? And once you have that, then you go to the east horizon, still at 0 degrees declination, about 25 degrees up above the horizon. And now you're seeing if the star, again, just drifts north or south. And if it does, you're adjusting the altitude, okay? And, you know, so you sneak up on it. Again, if you've gone the wrong way, you see that star drifting faster. If you're going the right way, it slows down or stops. And once you have it stopped, and you can test it for, I don't know, 5-10 minutes, you're drift aligned. And at this point, you got the best polar alignment possible because you're taking out all the issues of any kind of flexure that your telescope system might have, you know, any issue that might pop up. And there's several issues that could pop up when you're doing polar alignment. These are all addressed during drift alignment. So, but you're an astrophotographer, Simon. What do you find is the most popular method of polar alignment now?
In all honesty, it's going to be that QHY Polemaster.
Okay.
That to me is by far and wide the one that everybody uses. I use, I personally use SharpCap's polar alignment function, but I actually still go back in and do drift when I'm actually, if I'm setting up like just like remotely, then I don't care. You know, it's fine. The guiding will take care of that. But at home, once I get my mount set up, it doesn't move. So I will do the polar alignment just like I would do in SharpCap, but then I will sit down with the mount and then do the drift alignment through PhD because it does have the function to do it, and it'll even tell you, hey, you're going the wrong way, stop. So
Very cool.
That's the version that I prefer to use, at least anyway.
Sure. Well,
all right, let's move on.
All right, so let's bring in the EXOS 2 PMC-EIGHT. Okay.
Not how much heavier this thing was.
Yeah, it is heavier.
It's a little heavier.
All right.
Whew. There she is. The EXOS 2 PMC-EIGHT.
So all the things that we talked about with the EXOS 100 and the way that it works and the stepper drives and all the rest of that are really the same. The difference is that you're going to see that the electronics are in a separate box. Okay, so this is our heavy-duty PMC-EIGHT electronics box. You'll see that we did things like use DB9 cables. Okay. So if you lose a cable, you've taken a trip to Australia or something, or you're out somewhere remote, okay, doing astrophotography, and you forgot something like this, you can order one on Amazon. It's not a proprietary cable, okay, and so this allows you to hook up your right ascension and declination drives. We have the box itself. Thanks very much. Here we go. Has a little antenna, so you got some better reach here, okay? And it's really rugged. We've had people drop the box or whatever, so.
Not dropped it a lot of times during development work.
Right.
The beauty thing about this, Simon, is
knocked it off the desk, you know, rolls along the floor.
The
rolls.
I don't know how it rolls, but
your dogs chew on it, whatever. but very, very rugged. This is professional level electronics available for amateur astronomers. So, and this same box is on the EXOS 2, PMC-EIGHT, and the G11. We partnered with Lasmandi to develop, to modify the G11 to accept the PMC-EIGHT system. So if you need heavier yet payload capacity, the G11 is kind of where we go with that. But what else can I say that's a little bit different here? Payload capacity.
Oh yeah, big difference. Big difference between the little brother and the big brother. This is as a 28 payload capacity, 28-pound payload capacity. I like it. It's definitely another great setup that you can take, Simon, on the road. It's not heavy. It does come with two 10-pound counterweights, so you can put a C8 on there, possibly a C11, possibly. That's pushing it.
It depends on if you're going to do astrophotography or not.
True.
If you're doing visual work.
Visual, it's 40 pounds.
We put 88 pounds.
That's true, y'all did.
In the showroom and
you
put
did.
that in a video, which you can watch on YouTube, okay? We just kept stacking weights. In fact, we stacked all the weights that we had.
In the showroom that y'all had.
And then we were
that
putting
day.
weights up on top of the telescope and everything, just trying to see if we could actually break it during our video. But it ran and operated well. Nothing broke. When you get payload capacity quotes from manufacturers about equatorial mounts, really what they're talking about is the recommended payload capacity for the drive for an astrophotographer, okay? And so if you go to really too much heavy weight, you're going to change the characteristic of the periodic error.
Oh yeah, you'll start noticing a lot more of your mistakes too.
Yes, you will. Yes, you will. But as far as a lot of customers will think, oh well, the payload capacity is whatever, 10 pounds, 20 pounds, whatever it is. And if I go 21 pounds, that means the drive is going to break. Okay, the gears are going to be crushed. I'm going to wipe out a motor. No, that's not what that means. Okay, it just means that the mesh between the worm wheel and the worm itself will be different. Okay, because you're adding more weight to it, and that's going to change periodic error performance. Now, how much does it change? For a lot of our customers,
it hasn't changed a whole
lot.
They
don't see it change a whole lot. Okay, I imagine once we threw 88 pounds on this mount here, it would have
changed a little.
It would have changed more for sure, for sure. But anyhow, this is a workhorse mount. Will hold a lot of different types of telescopes. It's got a Vixen, saddle plate up here. And so there's a lot of scopes that will work on it.
Yes.
Okay. Including like our 6-inch Apo.
Correct.
Our 8-inch Photo Newtonian, with guide scopes and everything. So you can really get away with a lot with this mount.
I recommend this mount a lot for beginners.
Sure.
Because I think of it as, Scott or Simon, I know you have the EQ8R, but for this one, I always recommend this one because it's the foundation of a house. If you have a very poor foundation, you're not going to get anywhere in this hobby, especially for astrophotography.
Right.
So I always recommend, if you have the money, get the little bit bigger, heavy payload mount. That way you're saving yourself. You can always upgrade telescopes, and then when you over exceed what you're wanting to do, then, well, you'll see him here in a minute, the bigger brother.
Right.
I call him Big Daddy. And that's observatory grade. That's where you're on a pier, it doesn't move, and you're ready to go.
Okay.
One thing I would say, Tyler, about that though is that you want to buy a mount that's maybe a little bit more capacity to provide that margin in terms of what you buy, but our mounts provide margin.
They do.
They
really do.
Even if
already
you
have
can't
built-in
afford
margin.
more expensive mount, like from let's say it's $800 or $1,000 up to $1,500, and you just can't afford it.
Yeah.
With our mounts, we have plenty of margin in there to help you if you want to upgrade your weight.
Correct.
I think that's part of what we're talking about there in terms of the investment you have in this mount.
Yes, it's a big investment. It's a great investment too.
Okay, so a lot of people have also asked us, especially when we were developing the PMC-EIGHT, what about periodic error control? Okay, well, we didn't put a specific periodic error control system in here because, folks, there's a lot more going on with drive error than just periodic error. You know, there's tooth-to-tooth gear error. Jerry identified like 7 or 8 different types of gear error that there is. Periodic error is just one of them, okay? It is kind of a buzz marketing thing to say, oh yeah, you can correct out the periodic error, but okay, now you got 6 more to correct, okay? So there's a couple of ways to address this. One of them is an auto guider, of course, you know, and auto guiders came way down in price. They're very easy to use, very easy to set up. But the other thing that can be attached to this is an encoder system that gives direct real-time feedback that eliminates all those different drive error terms, and that's called the Telescope Drive Master. The EXOS 2 can take a Telescope Drive Master, and when Tyler brings over the G11, we'll show you where the Telescope Drive Master fits. And this is the system that we're setting up for some kids down in Brazil to operate the telescope remotely to do some astrophotography. So why don't we bring that one in here, and let me move this.
Okay. You got any questions, Simon, about the EXOS 2?
Mainly, how heavy is the damn thing?
Well, with counterweights, guesstimating
35?
Yeah, right. It's probably about 65, 70 pounds total.
In terms
Maybe.
of portability, is it just as equally as portable as all the other mounts out there? Because I think that's the biggest thing is we've seen the EXOS 100, which is like you're just straight up grab and go, panic, let's get the heck out of here type scenario. The EXOS 2 GT, where does that category fit in, or does it still fit into that category of panic, grab and go?
I mean, it depends on.
I would say that our EXOS 100 is definitely grab and go. Okay,
Yes.
is solidly there. I would say that this smaller EXOS 2 PMC-EIGHT mount is what I would call a portable mount. Okay?
Correct.
Absolutely portable. That when you take the head off without counterweight, you know, he's lifting all these counterweights and everything on here, but without the counterweights, that head is under 15 pounds.
Yes.
Okay? That tripod is about 25 pounds. Okay. You got two 10-pound counterweights. You got the box. You got maybe your batteries. You know, this kind of thing. So okay, the weight overall, the package is going to add up, but it's solid. Okay.
I mean, the beauty thing is it can collapse pretty easily.
True.
I think it's a little bit lighter than the EQ6.
The EQ6R Pro
class mount.
Yeah.
And it'll almost carry the same capacity as an EQ6. Not quite there, but it's very close. And so I think overall, in terms of portability, it's as at least they're more portable than the other mounts that are out there in that class. EQ5 class mount, I guess you could call it. The Sirius mount from Orion.
Yes.
How do you compare that against something like the VX mount, which is like one of the most popular mounts out there, Jerry?
This EXOS 2 mount goes head to head, I think, against the AVX, and it's got upgraded mechanical. It's got bearings and everything.
Yeah,
where
it's
the
ball
AVX
bearings on
doesn't.
both axes.
It's got our
Belt
high
driven.
performance control system, of course, and so
Again,
in terms
belt-driven
of weight
drives.
capacity, I'm not sure what the demonstrated weight capacity is of the AVX, but I can guarantee
Jerry, I believe
that
on
it's at
that
least
one
what
it's-
the AVX can carry, if not more.
Well,
Yeah,
I
no,
think
it's
on the
more than
AVX.
VX. Yeah.
Go ahead, Simon.
Sorry, I was just saying it's. I think it is. The weight capacity is more than what the VX does, from what I can tell.
Yes, I think the AVX total weight, if I'm wrong, it's been a while since I've had one. The max I could put on that one was less than 15 pounds. Was the AVX.
Well, one of the things I noticed, just looking at their specs, is they don't give you a spec for astrophotography and for visual. Okay? They just throw a number out there. What does it mean? I don't know.
Yep.
So that would be a question I would ask them. What does your number actually mean? Is it for visual or is it for astrophotography? I might get back an answer like yes Yes, it is. But they really are two different numbers. Okay, so all right, so let's bring in the G11.
Oh boy. He's a big
Hey, Scott,
boy.
is there any way to move that light that's right in the middle of the frame?
Stand by, Simon.
He's doing it. Yeah.
Gotta move some sandbags. How's that? Well, that's,
Yes, there we go.
how's that? Is that
That's
better?
perfect. Right there's right fine.
Okay. Give me a minute. Okay. Now, the Losmandy G11, if no one's familiar with the Losmandy G11, on paper. Now,
Oh,
this is
you
on
cheated.
paper.
You had it on wheel.
Yeah, and he's
of course he's
I
got
got this thing heavily modified, guys.
It's on wheels. It does not come on with wheels. The beauty part about the Losmandy G11 is on paper it'll hold 60 pounds. That's on paper. I could probably guess this thing would probably hold 100 pounds easy and just keep on moving. We haven't tested that theory yet because, well, Scott.
We've loaded up the observatory G11 up to 75 pounds for astrophotography, and it worked fine.
Yeah. But Jerry,
yours is also with the TDM,
though, correct?
Yeah, it's got telescope drive master. It's on a solid pier, you know. So how it's mounted, but I have to say that the G11 tripod is like a rock. I mean, it's no different than a concrete pier in the
Much
ground
heavier
when you get it
duty
set up
tripod.
correctly.
Yeah, because it's
It's
loaded
amazing
around,
how
Simon.
solid it is once it's set up.
So Simon, if I extended the legs all the way up, it would be as tall as me. And I'm 6'2". So I would literally be looking dead on with this camera sitting right here. So she's a heavy girl. She definitely is. But the beauty part about it is, the great thing about it is, let me turn it real quick. I love these wheels. I'm glad Scott did this. Is you have these two clutches or release knobs that are right here. I don't know if can you see these, Simon?
Yep.
Okay, so with the ability with the Losmandy G11, we got with Scott Losmandy, we added the RA extension. So this is semi-portable, which is great. The head, the deck head weighs 33 pounds. The RA weighs 33 pounds. And the tripod, I believe, is another 20-ish?
Oh, it's more than that.
Yeah, well, we'll say around 30-ish.
Yeah,
But you release these, and this head will literally just come off. So it's 3 pieces.
Now, the other thing that the RA extension does is it adds some space so that you can go through the meridian with it. Okay,
that is
so
also
you can
true.
keep tracking with it. So
Track past the meridian as far as you dare to go.
It will.
Yeah, a lot
and
of
that's-
systems actually have hard stops or software stops. I mean, that's actually a good point to raise. The PMC-EIGHT actually has some of these things built into it, if I remember correctly.
right. You'll see that we added a little shelf here. We 3D printed a shelf.
Turn
On
your
top of
toes.
that shelf is a NUC computer. Okay, so it's running Windows 10. Okay, and on Windows 10 we've got all of our software. We've got our planetarium software connected to the PMC-EIGHT box. It's just down here, and it's got Zoom on it. And so the idea here is that I just connect this to the internet, start a Zoom session, and let kids from this, the first test of this is going to be a group of, they're called the Young Stars of Tomorrow. This is a program that Dr. Marcello Souza started in combination with Explore Scientific's mentor program. And they're going to do science with this telescope. And this is literally the same kind of setup that they have at the Mark Slade Remote Observatory, but I'm just running a little 4-inch on here with an ED80. The ED80 is either a wide field scope, wide field astrophotography, or guide scope, and then the ED102. So, I think 4 inches is probably about the minimum aperture that you could do for exoplanet work. And so, and I know from direct experience that the Mark Slade Remote Observatory does exoplanet work day in, day out with their system.
So Scott, you were talking about the
came in right off the bat, and it's a bit more generic though. Should I buy a mount before I buy a camera? And I suppose I could say the same thing as should I even buy a telescope? Which should you get first is the best question, I think.
This is a if you're asking me, I think that you need to buy the mount first, okay? All right, but you need to already know in your mind, okay, what range of scopes you might be thinking in, okay? Here, I mean, we've got the G11 driving a little teeny tiny 4-inch refractor, okay? This is like taking a sledgehammer to a thumbtack, okay? I can operate this in wind. Nothing's going to bother this telescope while I'm out there making astrophotographs.
See, I always ask customers, what do you plan on looking at? What do you plan on doing? Are you wanting to do astrophotography? You want to do visual? Are you wanting to just do planets? Or are you wanting to do deep sky objects? And I always, like I said before, Simon, I always recommend the EXOS 2 PMC-EIGHT because it's a great starter beginning mount, and it can progress to almost an intermediate mount depending on the user. Because it's a great start. Think of it as a house. Without a great foundation, you're not going to have success. But when you have great foundation, you can have the tools to build upon on that platform. So always look at the mount capacity is always a good thing to look at. And what do you plan on putting on top of that platform?
Yeah, you may have a variety. Most amateur astronomers have certainly more than one telescope. I know guys that have 20 or more telescopes, okay? If you have a larger mount and a set of counterweights to complement it, you can put almost all your scopes on it as you want to use these things, okay? The G11 for me is a high precision mount by itself anyways, okay? Just the native periodic error rating on it from Losmandy is plus or minus 5 arc seconds. I mean, that's right out of the box. When you're auto-guiding it, certainly you can get down to the 1 arc second range. If you put a telescope drive master on here, and for some reason we took mine off, so they're looking at it for whatever reason. But the telescope drive master can take it down to sub-arc second tracking, almost down to 0.
Yeah, pretty close. You're talking 0.2.
And now you have a mount that costs, granted this mount's...
It's $4,100.
Right.
It's an expensive...
But what other mounts in the $4,100 range can get down to almost 0 periodic error or 0 drive errors? Let me rephrase that, okay? Because we've got mounts like the Bisque Paramount. We've got
Ioptron.
Yeah, I don't know that they even track. I don't think that they make those kinds of claims. 10 micron is
10
another.
micron.
It's a high performance mount. But they range into
Silly
the many
money now.
thousands
All
of
the
dollars.
mounts you're listing are all $6,000+ dollars.
Exactly.
That's true.
It's true.
When you're wanting the better tracking, you're gonna pay for it. You're honestly, I mean, what's astrophysics has a mount that's 10 grand.
10 grand
starting out. That's
The Mark II.
That's out of my budget.
But anyway, great. I mean, those are all wonderful mounts, and if you've got the money, go for it. Okay, but you could take the thousands of dollars you might otherwise save and throw it into your next camera, okay, or your next computer system, or maybe, how about this, an observatory? Okay, we also sell observatories. So, so these are other things that you need, to make you a more productive astronomer than you might be otherwise.
Yep.
See, this is the thing I like about a lot of your products, Scott, is you guys aren't really basically aiming for the top echelon right off the bat. You guys are looking and listening for what people actually want, and that's the part that I love the most. I mean, I remember when the GT2 or the 2GT, whichever way you want to call it, I remember when that first came out, and it filled a gap in the market for us where people wanted, say, the VX mount, but we didn't have anything, but they wanted something comparable. And I would always tell them, it's just like, this isn't a comparable mount. This can actually exceed your expectations based upon how you actually utilize it. And when that little EXOS 100 showed up out of thin air, I was like, where's this been all my life? You know, so that's the thing. I love the fact that you listen to people.
Well, we are focused very much on educational outreach, beginning astronomy, where you're not just going to do gee whizzes at the eyepiece and it's a novelty, but you might be entering into the lifestyle of astronomy, and you need the right kind of gear to get started. Granted, you might, as you grow in your lifestyle, you may end up with the most grand observatory and the biggest telescope and the world's most expensive cameras and all of that. But we all start off, we have to learn. We have to learn how to do it. And having a system that's flexible enough, professional enough, high precision enough to get the job done is important without breaking the bank account. So.
Right, that's the important part.
I think Scott started the company understanding that he wanted to create high value products, which are basically 90 to 95% of the performance for half the cost, basically, is what the goal is, right?
That's right.
I mean, you can always pay twice or three times as much to get that last 10 to 5% performance increase, right? But most people don't need that last 10%. They just want a very high performance scope that's not the best, but it gives them high value because it costs half as much.
Now, I've taken the G11 mount out to expeditions. I've been to two Eclipse expeditions, the Casper, Wyoming event with the Exploratorium group, a professional eclipse chasing team out of San Francisco chose us to be there for backup initially at the 2017 eclipse. And guess what? One of their big mounts failed, okay? And we were there with working G11 mount running PMC-EIGHT, and we got their camera on there with an H-alpha system, and we got the eclipse live, which was live streamed through NASA's channels and all the rest of it. Then we were invited to Chile for the 2019 eclipse, and we went to the CTIO observatory complex up there, and that was amazing. And they used two of our mounts. One was a wide field, and one had a small telescope on it. But and that complemented a kind of a more massive Paramount that was also running a larger system. But we were there and we got the job done. So.
Question for Jerry. I have an EXOS 100 and it seems like only one application can communicate to it at a time. This limits my session because I use APT and PhD2 at the same time. That's a common thing. So ASCOM, there's different types of interfaces. The PMC-EIGHT has a driver. It's called a driver. It's not a server. So what you're looking for and what we recommend to people is to use the POTH, which is a hub, which is the legacy hub device that allows you to connect multiple ASCOM client programs like CART2SEAL and MaximDL simultaneously, or you can use a newer device hub under ASCOM to connect all your applications to the device hub, and then the device hub connects to the PMC-EIGHT, and it's kind of like the manager that directs commands into the PMC-EIGHT from all the different clients. So if your client, like a planetarium program, is keeping track of your location on the display, that can connect up, and then you can have APT, which drives it, maybe also, or records information off of the mount coordinates. It records that data. It can get that data for you. Any other applications you want to connect up to the PMC-EIGHT can be connected through one of these device hubs or the POTH. That's basically how you have to do it. Awesome. Just out of curiosity, Jerry, do you think that you guys are going to have ASCOM Alpaca for this out of interest?
Yeah, I've been studying Alpaca over the last couple of years. I'm pretty good friends with Bob Denny in the ASCOM community, and that's on my list. as you can imagine, there's probably 10 different things on my list to get done. That's definitely on my list to upgrade the driver to support Alpaca cross-platform connectivity. So yes,
Right.
that's on the radar.
Let's talk a little bit about the Open Go-To community. The software and the firmware that run the system are contributed by a community of hundreds of people that have joined up on groups.io, and they are directly driving features, directly driving performance. Okay, this community is creating the kind of go-to system that they want. Okay, working in a previous company, all this stuff was super secret, patented. And the idea was that the company was going to tell you how to do go-to astronomy, and that was what you were left with. You had to learn their system. Okay.
But we don't do that here.
We have not done that here. I'm proud to say that, but it's really cool because we are working with some really brilliant amateur astronomers that are / programmers. Okay, that are really driving and tweaking the system. So when we run into an issue, like any programmer or supplier of astronomical software does, occasionally we run into a bug or something like that. These guys, everybody just jumps on this, okay, and we take care of it right away. Okay, so that we've had it before. We're running through a couple of niggles right now, and we'll have in the future. But the difference is that the community pretty much owns this operating system and owns this this software. God forbid. I mean, if I win the lottery and win hundreds of millions of dollars, and Scott says he wants to go to Australia to Ayers Rock and go stare at the southern Milky Way for the rest of his life, there still will be a community to support the PMC-EIGHT system. Okay, so if that day ever came, which would be a tragedy and a wonderful thing at the same time,
You'll still be here.
I'll still be. I know I will. I'll still show up for work.
You'll still show up for work.
That's right. Hey, I was bored, So that's right.
Working hard to build that community and to and it's a work in progress for sure, but we've made good progress over the last few years in the Open Go-To community.
That's right.
I want to specifically thank Wes McDonald for his invaluable help over the last year or two. He's now the firmware is not open source, of course. We guard that pretty heavily, but we brought Wes from the Open Go-To community to help because of his expertise and knowledge.
What I need to say
help
about that,
bring
this
these
community,
firmware updates more
this community
faster
has
to
brought
the community.
forward people like Wes. Okay.
Yep.
So these are not employees of Explore Scientific. These are people that have joined up with us, to push the performance and the reliability of the system.
Correct.
Okay, I got two questions. I'm going to start with the easier one first. Technical support. Where do we go?
Wow. Okay.
I'll be darned.
We've got one of the leaders of our technical support team right here with us, and that's Tyler Bowman. Okay. We have Jerry Hubble also has done technical support. One of the cool things in today's world is that we're able to log into people's computers remotely. We have shown people how to configure their system so that it works with the PMC-EIGHT. Sometimes there's people that just run into a problem and they're just batting their head against the wall and they can't figure out why, and it ends up being a configuration problem where they're running something else, or they haven't turned something off, or Windows is doing something in the background that's preventing a good connection. Okay. On one occasion, I remember Jerry Hubble and I were on. We do a live program every day, and one of those programs is called the Open Go-To Community. And on one of these programs, we had a guy come on the show live, could not connect. Okay.
He was an audience member at first, wasn't he?
Yeah, he was.
And
he
posted a question, saying he could never connect.
So he could not do it. So he said, "Okay, we're going to do this live." Okay. Now, you know, a lot of manufacturers would not risk doing something live because probably what's going to happen if you do it live is just going to blow up in your face, right? So I said, no, we're doing it live. Okay, so he gets on and we configure and make this telescope system run live during our show, okay? And that put a big smile on my face, you know, and it put a bigger smile on the customer's face, you know. But these are some of the things that we can do. I asked recently for Tyler and Kent Martz, who also is very involved in technical support, to give me a rundown of our first 1,000 EXOS 100 mounts. I just wanted to see what the reliability was like, okay? I'll be very transparent with you. We had 36 credit memos, okay, out of 1,000. And you're going, okay, well, the credit memo, what is that, a defect, something like that? No, I mean, credit memos are issued to dealers and customers based off of any reason for a return. And we had, so out of that 36, we had 2 of them that were due to what you would call a physical problem, okay? On one of them, the customer had pushed in the USB port too hard and had broken a USB port on it, all right? Another one we had where the
It's firmware
was corrupted, okay? We were able to, of course, fix the broken USB port, and we were able then to just go and you know, delete what he had in the board on the other unit and reprogram it, and it was working just fine. The other 34 units, we had returns because of shipment damage. We had a dealer that had some overstock. It was issues like that. So out of 1,000 right now, okay, that I had them do this analysis of, actual real defects where you're just going right out of the box, DOA doesn't work, 0.
Gotta love it.
0. Okay, so that is really a almost impossible level, defect level to maintain. I'm not going to guarantee I can do that forever, but you know, out of 1,000 units to have 0, and after working in this industry, not only for my company but for other companies as well, I would say that 0 is phenomenal. So I was really, really happy about that.
So that was the #1 goal that Scott had for this product when he came to me back 8 years ago now to design the system. #1 reliability was foremost. That's why you see that big box on the first edition of the PMC-EIGHT. Well, that's on the G11 and the EXOS 2, because it's all about reliability, and
right.
So
right.
that's why we designed it that way, and then we were able to push down that technology and I'm surprised at that reliability level also. But that talks to you about not the work that I've done, but in terms of the work we do in our manufacturing plant to create a quality product and deliver it. Because the manufacturing and getting the correct components is a large part of that, which I did have something to do with. But mil-spec parts, conformal coatings, you know, all kinds of things in terms of making the thing work and work all the time.
Right.
Is a big deal to Scott and to me.
And Jerry, you'll even remember when we first started, I wanted to have waterproof connections, okay? And the way I was going to show this is this thing underwater running, okay? But we found out that each waterproof connection was going to raise the overall price of the PMC-EIGHT by like way too much money, okay?
Connectors are expensive.
They're very, very expensive. You know, even
the original design of the box
level.
also had an O-ring on the cover plate.
And we do have that. So this is really designed. This box is and the embedded EXOS 100. These electronics are designed to be working outdoors.
So they can get wet a little bit?
Yes, they can get wet a little bit. So humidity is not going to really be a problem. You know, I expect that these electronics are going to work for 15, 20 years, no problems.
Good.
In
I can
fact,
tell you,
Mark
I've
Slade
had
Remote
the
Observatory is on all the time, isn't it?
I've had the PMC-EIGHT at the observatory running for the last 4 years, on all the time.
24 hours
Except
a
for
day.
outages, it's been powered up the whole time.
Right.
So let's do this last question real fast. Anybody could just pitch into this question, and I like this for a reason. Where should I start it from? Okay, would you ever recommend go-to telescopes for absolute beginners?
Sure. Why not? Now, what I would not recommend is a go-to system where you could not release the locks of the mount and operate it manually, okay, for a beginner. You know, if you are building up an observatory station and you know, everything is going to be computerized, yeah, okay, choose a go-to mount that only runs when it's got power. Fine, okay? But if you're a beginner, all right, and you don't want to hook up the computers and you don't want to do anything, you just want to grab it, haul it outside, go see Comet Leonard or something, you're going to be out there 5-10 minutes. Yeah, you want a system that you can release the locks, move it, adjust it manually by hand, okay, fine. If you don't want to use all the, if you think it's cheating or cheating yourself out of learning the sky, you can still use the mount as a regular tracking mount. The PMC-EIGHT, if you don't have anything hooked up to it, okay, but you just turn it on, just drives in right ascension, right?
Feature that we added with this latest firmware is that you can track on boot, basically, where you don't have to communicate with a computer at all. It acts like a legacy mount, like a traditional mount back in the 60s,
you know,
70s.
if you're
It just drives, and you can move it
old
around
enough to
manually to
remember
point to any object in the
Cave
sky and tighten the clutch, and
right?
you can look at whatever you want.
Look at what you want. Right, but you're running with stepper drives that are really quiet, like the old AC synchronous motors are really quiet, you know, but you're running off of batteries and it's just super easy. And then challenge yourself all night long. Do the Messier Marathon, do, you know, go after the Herschel list, you know, all these things, you know, star hop, use setting circles, whatever, okay? You know, yeah, I would recommend it. And then when you want to do something like, you know, go through a list of 200 galaxies to search for supernova, it really does help to have a go-to system.
It does.
Okay, because you can concentrate then on your research and getting data rather than going, okay, do I remember how to find NGC 891, okay, and pulling out the star charts and all the rest of it. You can build a script, go after all this stuff, and be, so you can be as rudimentary, as organic astronomy as you want with the PMC-EIGHT mounts that we have, okay? Or you can go as advanced as you want to, for, you know, including full remote, fully scripted, fully absent type of astronomy, you know, where you wake up in the morning and go look at data.
Oh, who's that creeping in again? Oh, hey!
Right.
Okay. Oh, sorry, just knocked something over.
All right.
Okay, Scott, thank you very much for doing this.
Thanks, Simon. Thank you.
And like I said to everybody who's watching the stream, this is more like I kind of just like butted into what Scott was doing for his like just general day-to-day thing and said, hey, do you mind if we slide in and do something like that? So excuse the crudity of how all of this is. But thank you very much for coming on, Tyler. Thank you, Jerry, for making an appearance, and of course the trash guy that has to drive past in his truck right now. Thank you. Yeah, go away. Okay.
Right. And I know that we're also streaming on to, I know you're streaming to your audience, Simon. We're also streaming to the Explore Scientific audience. I couldn't be on chat like I normally am, okay? So all of you guys that are watching right now, thanks very much for tuning in. And, you know, keep looking up. We have more programming coming up, and we'll do more with Woodland Hills in the future. So just say the word, Simon, and we'll do it, okay?
Live stream at night
And I love it.
just randomly.
I love it. Yeah, it's great.
Actually, before we run away, just quick chat about that, because I think a lot of people who look at our live stream doesn't necessarily know about the Explorer Alliance Live.
Yep. Explorer Alliance Live, we do a live program every Monday through Friday. We occasionally do special programs like where we have scientists on from like the Jet Propulsion Laboratory and stuff. We had Alan Stern from New Horizons come on with us. We had Dr. Rosalie Lopez, from JPL NASA, that interviewed what's being called the world's youngest research astronomer, which is Nicolina. She's 8 years old, and she's down in Brazil. She's doing asteroid research. She has given lectures and interacts with NASA scientists and all the rest of it. Really sweet little girl, but really smart, okay? And so that's really cool. And those are called the Explore Now series, and they just kind of come up as we can put them together. On Tuesdays, typically on Tuesday nights, starting about 6 o'clock Central, we have something called Global Star Party. I started Global Star Party because we were all locked down in the pandemic. We couldn't go to real star parties. So I said, God, wouldn't it be fun to get my friends from around the United States, and then I thought, okay, around the world, and to share live views through their telescopes, to talk about what's going on in their corner of the world, okay? And so we have done 76 Global Star Parties. Next Tuesday will be the 77th Global Star Party. And they start at 6 p.m. Central, a lot of times going to like 10, 11, 12, 1.
3 in the morning.
Really late, okay, sometimes.
You're those late ones.
But and we literally reach around the world. We have astronomers sometimes chiming in from Australia, Asia, the UK. We have a contingent from Argentina that's on almost every time, and Simon Tang, of course, comes on as well. So we'll have nighttime astronomy, live imaging sometimes of galaxies and stuff, and Simon will come on with a live image of the sun. So there's no other way to have a global star party except to do it in a virtual way. Okay, and so for those of you that might be watching, you go, that sounds like fun. I'd like to participate. Just get in touch with us at Explore Scientific. You can call customer service, and they'll get you hooked up. And we try to keep those presentations short. That's not always possible, but we try to keep them short, down to about 10, 15 minutes max. And so it's bite-sized astronomy, but you're showing the world your passion, your knowledge, okay, your interests, and a lot of times, an important message about protecting dark skies, forming astronomy clubs or whatever, because astronomy is good for you, and so I think it's gotten a lot of people through this pandemic that might have otherwise just kind of lost their minds, that they couldn't go out and interact with other amateur astronomers as they are, wanting to be part of a
I gotta say, I think a lot of people in the astronomy community, as well as the vendors, I have never seen anybody get together during the pandemic as much as we did, because we all did live streams. I mean, I think we just lived off of there for a while.
That's right.
And it was great to have that link with everybody again.
That's right.
And that was the scary part. It was like, oh my gosh, what's going to happen? It's just going to be me in a dark field on my own inside of a plastic bubble, not trying to catch COVID,
So we have people during global star parties that were just setting up like their tablet, running global star party, okay, watching on YouTube. Or we're simulcasting, okay. And Simon's done this with me and has shown me a lot of tricks, by the way, which I really appreciate Simon. He's a real pro. But they'll set up their telescope in their backyard doing astrophotography or whatever, and then hear the banter of Global Star Party in the background. So they're kind of simulating actually being at a real in-person star party, so that's pretty fun.
That's the thing, it's more exciting. I think one of the things that I remember was when I set up the C14 and we had Jupiter.
That's right.
And I had to butt in constantly because oh my God, we've got good seeing.
Yeah, it was
and
remarkable.
We would see that clear image.
Right, yeah, and he was broadcasting it around the world, so a lot of fun. But Woodland Hills has also done a lot of this themselves, and they have participated at trade shows where they were there virtually, and they really know how to bring their game on. And a lot of that technology, again, I'll attribute to Simon because he knows how to pull it off. So good job, man. Really good.
Really good. All right, guys, thank you very much for watching. If you have any other questions for either myself, Scott, or whoever, you can find us on telescopes.net or explorescientificusa.com. Is that
Yep.
right? Okay.
If you want to buy one of these systems, you can go straight to the link that we publish on our live streams, okay? And it'll take you right to the Explore Scientific store at Woodland Hills, or otherwise just go to telescopes.net and you can find our stuff and scads of other products, including cameras, eyepieces, other mounts, other brands, and stuff like that. The time to get into amateur astronomy is now. Okay, we are living in the golden age of astronomy. We're about to launch the James Webb Space Telescope, and that's about to change everything we know about astronomy. Okay, so it's going to be a cool time. So, you guys, if we don't see you again, if we don't do another Woodland Hill stream, you guys have a great holiday. If you have questions, of course, get in touch with us. If you find our lines busy, it's because we're crazy busy right now. So, but don't give up on us. Everybody is. Everybody is. Right.
Everybody on the live stream, good night, God bless, and I will see you the next time.
We'll see you. Thanks. Take care.
Okay, we're clear.